Question 1. 0.48 grams of magnesium is mixed with 40 cubic centimeters of 0.3 molar hydrochloric acid. Find the limiting reagent, the maximum hydrogen volume at STP, and the mass of magnesium remaining. The balanced equation is magnesium plus 2 hydrochloric acid, producing magnesium chloride and hydrogen. Moles of magnesium equals 0.48 divided by 24.3. This gives 1.98 times 10 to the minus 2 moles. Moles of hydrochloric acid equals 0.3 multiplied by 0.04. This gives 1.2 times 10 to the minus 2 moles. Place these starting amounts in the I row of the ICE table. Using the 1:2 ratio, hydrochloric acid decreases to 0. Magnesium decreases by 6 times 10 to the minus 3 moles, and hydrogen increases by the same amount. Therefore, hydrochloric acid is limiting. Multiply the hydrogen amount by 22.7 to get 136 cubic centimeters. The magnesium remaining has a mass of 0.334 grams. The final answers are hydrochloric acid is limiting, hydrogen is 136 cubic centimeters, and 0.334 grams of magnesium remains. Question 2. 5.4 grams of aluminium reacts with 10.65 grams of chlorine. Find the limiting reagent, the maximum mass of aluminium chloride, and the mass of excess reactant left. The balanced equation is 2 aluminium plus 3 chlorine, producing 2 aluminium chloride. Moles of aluminium equal 5.4 divided by 27. This gives 2 times 10 to the minus 1 moles. Moles of chlorine equal 10.65 divided by 70.9. This gives 1.5 times 10 to the minus 1 moles. Enter the two starting amounts in the I row of the ICE table. The 2:3 ratio means 1.5 times 10 to the minus 1 moles of chlorine uses 1 times 10 to the minus 1 moles of aluminium. Chlorine reaches 0, so chlorine is limiting. 1 times 10 to the minus 1 moles of aluminium chloride has a mass of 13.3 grams. The aluminium remaining has a mass of 2.7 grams. The final answers are chlorine is limiting, 13.3 grams of aluminium chloride forms, and 2.7 grams of aluminium remains. Question 3. 4.2 grams of nitrogen is mixed with 0.6 grams of hydrogen. Find the maximum mass of ammonia and the mass of excess reactant remaining. The balanced equation is nitrogen plus 3 hydrogen, producing 2 ammonia. Moles of nitrogen equal 4.2 divided by 28. This gives 1.5 times 10 to the minus 1 moles. Moles of hydrogen equal 0.6 divided by 2. This gives 3 times 10 to the minus 1 moles. Place the initial nitrogen and hydrogen amounts in the I row of the ICE table. The 1:3 ratio means 3 times 10 to the minus 1 moles of hydrogen uses 1 times 10 to the minus 1 moles of nitrogen. Hydrogen reaches 0, so hydrogen is limiting. 2 times 10 to the minus 1 moles of ammonia has a mass of 3.4 grams. The remaining nitrogen has a mass of 1.4 grams. The final answers are hydrogen is limiting, 3.4 grams of ammonia forms, and 1.4 grams of nitrogen remains. Question 4. 2.5 grams of calcium carbonate is added to 30 cubic centimeters of 1.5 molar hydrochloric acid. Find the limiting reagent, maximum carbon dioxide volume at STP, and calcium carbonate remaining. The balanced equation is calcium carbonate plus 2 hydrochloric acid, producing calcium chloride, carbon dioxide, and water. Moles of calcium carbonate equal 2.5 divided by 100.1. This gives 2.5 times 10 to the minus 2 moles. Moles of hydrochloric acid equal 1.5 multiplied by 0.03. This gives 4.5 times 10 to the minus 2 moles. Enter these initial amounts in the I row of the ICE table. The 1:2 ratio means the acid uses 2.25 times 10 to the minus 2 moles of calcium carbonate. Hydrochloric acid reaches 0, so it is limiting. The carbon dioxide volume at STP is 0.511 cubic decimeters. The remaining calcium carbonate has a mass of 0.248 grams. The final answers are hydrochloric acid is limiting, carbon dioxide is 0.511 cubic decimeters, and 0.248 grams of calcium carbonate remains. Question 5. 8 grams of iron 3 oxide reacts with 3.18 cubic decimeters of carbon monoxide at STP. Find the limiting reagent, maximum mass of iron, and carbon dioxide volume at STP. The balanced equation is iron 3 oxide plus 3 carbon monoxide, producing 2 iron and 3 carbon dioxide. Moles of iron 3 oxide equal 8 divided by 159.7. This gives 5.01 times 10 to the minus 2 moles. Moles of carbon monoxide equal 3.18 divided by 22.7. This gives 1.4 times 10 to the minus 1 moles. Place these starting amounts in the I row of the ICE table. The 1:3 ratio means carbon monoxide uses 4.67 times 10 to the minus 2 moles of iron 3 oxide. Carbon monoxide reaches 0, so it is limiting. The maximum iron mass is 5.22 grams. Carbon monoxide and carbon dioxide have a 1:1 ratio, so the carbon dioxide volume is 3.18 cubic decimeters. The final answers are carbon monoxide is limiting, 5.22 grams of iron forms, and carbon dioxide is 3.18 cubic decimeters. Question 6. 425 cubic centimeters of hydrogen is measured at 298 Kelvin and 102 kilopascals. Calculate its volume at STP, where the temperature is 273 Kelvin and the pressure is 100 kilopascals. Because both pressure and temperature change, use the combined gas law. P1 V1 over T1 equals P2 V2 over T2. Rearrange the equation to make V2 the subject. Substitute the values. Multiply 425 by 102 over 100 and by 273 over 298. The volume at STP is 397 cubic centimeters. Question 7. 25 cubic centimeters of sulfuric acid requires 22.4 cubic centimeters of 0.15 molar sodium hydroxide. Calculate the concentration of the sulfuric acid. The balanced equation shows 1 mole of sulfuric acid reacting with 2 moles of sodium hydroxide. First, calculate the sodium hydroxide amount. It is 3.36 times 10 to the minus 3 moles. Now use an ICE table. Put the known sodium hydroxide amount in the initial row. At the endpoint, both reactants have reached 0. Using the 1:2 ratio, the sulfuric acid amount is half the sodium hydroxide amount. It is 1.68 times 10 to the minus 3 moles. Divide the sulfuric acid amount by 0.025 cubic decimeters. The sulfuric acid concentration is 0.0672 moles per cubic decimeter. Question 8. 10 cubic centimeters of vinegar is diluted to 250 cubic centimeters. A 25 cubic centimeter sample requires 18.6 cubic centimeters of 0.1 molar sodium hydroxide. Find the original acid concentration. Ethanoic acid and sodium hydroxide react in a 1:1 mole ratio. The sodium hydroxide amount is 1.86 times 10 to the minus 3 moles. Place that amount in the initial row of the ICE table. Both reactants reach 0 at the endpoint. The 1:1 ratio gives 1.86 times 10 to the minus 3 moles of acid in the sample. Divide by 0.025. The diluted acid concentration is 0.0744 molar. The dilution factor is 250 divided by 10, which is 25. The original vinegar concentration is 1.86 moles per cubic decimeter. Question 9. 25 cubic centimeters of sodium carbonate requires 20 cubic centimeters of 0.2 molar hydrochloric acid. Calculate the sodium carbonate concentration. The balanced equation gives a 1:2 ratio between sodium carbonate and hydrochloric acid. The hydrochloric acid amount is 4 times 10 to the minus 3 moles. Put the known acid amount in the I row of the ICE table. At the endpoint, the 2 reactants are used up. Divide the acid amount by 2. The sodium carbonate amount is 2 times 10 to the minus 3 moles. Divide by 0.025 cubic decimeters. The sodium carbonate concentration is 0.08 moles per cubic decimeter. Question 10. 20 cubic centimeters of ammonia requires 24.6 cubic centimeters of 0.125 molar hydrochloric acid. Calculate the ammonia concentration. Ammonia and hydrochloric acid react in a 1:1 mole ratio. The hydrochloric acid amount is 3.075 times 10 to the minus 3 moles. Put the acid amount in the initial row of the ICE table. Both reactants reach 0 at the endpoint. The 1:1 ratio gives the same amount of ammonia, 3.075 times 10 to the minus 3 moles. Divide by 0.02 cubic decimeters. The ammonia concentration is 0.1538 moles per cubic decimeter. Question 11. 1.5 grams of limestone reacts with 50 cubic centimeters of 0.5 molar hydrochloric acid. The excess acid needs 18 cubic centimeters of 0.2 molar sodium hydroxide. Find the percentage of calcium carbonate. Calcium carbonate reacts with hydrochloric acid in a 1 to 2 mole ratio. The initial hydrochloric acid amount is 2.5 times 10 to the minus 2 moles. The back titration shows that 3.6 times 10 to the minus 3 moles of acid remain. In the ICE table, place the initial acid in the I row and the remaining acid in the E row. The acid change is 2.14 times 10 to the minus 2 moles. Divide by 2 to obtain 1.07 times 10 to the minus 2 moles of calcium carbonate. The calcium carbonate mass is 1.071 grams. The limestone is 71.4% calcium carbonate. Question 12. 0.8 grams of antacid reacts with 40 cubic centimeters of 0.3 molar hydrochloric acid. The remaining acid needs 15 cubic centimeters of 0.2 molar sodium hydroxide. Find the percentage of calcium carbonate. Calcium carbonate and hydrochloric acid react in a 1 to 2 mole ratio. The initial acid amount is 1.2 times 10 to the minus 2 moles. The back titration shows that 3 times 10 to the minus 3 moles of acid remain. Place the initial acid in the I row and the remaining acid in the E row of the ICE table. The acid change is 9 times 10 to the minus 3 moles. Divide by 2 to obtain 4.5 times 10 to the minus 3 moles of calcium carbonate. The calcium carbonate mass is 0.45 grams. The antacid is 56.3% calcium carbonate. Question 13. 2.46 grams of hydrated magnesium sulfate leaves 1.2 grams of anhydrous magnesium sulfate after heating. Determine X. The water mass is the hydrated mass minus the anhydrous mass, giving 1.26 grams. Divide by 18. The water amount is 7 times 10 to the minus 2 moles. Divide 1.2 by 120.4. The magnesium sulfate amount is 9.97 times 10 to the minus 3 moles. Divide both amounts by the smaller value. The ratio is about 7 to 1. Therefore, X is 7, and the formula is magnesium sulfate heptahydrate. Question 14. 7.15 grams of hydrated sodium carbonate leaves 2.65 grams of anhydrous sodium carbonate after heating. Determine X. The mass of water lost is 4.5 grams. Divide by 18. This is 0.25 moles of water. Divide 2.65 by 106. This is 0.025 moles of sodium carbonate. The water to sodium carbonate ratio is 10 to 1. Therefore, X is 10, and the compound is sodium carbonate dehydrate. Question 15. 1.26 grams of hydrated oxalic acid is made up to 250 cubic centimeters. A 25 cubic centimeter sample needs 20 cubic centimeters of 0.1 molar sodium hydroxide. Determine X. Oxalic acid is diprotic, so 1 mole reacts with 2 moles of sodium hydroxide. The sodium hydroxide amount is 2 times 10 to the minus 3 moles. Put the known sodium hydroxide amount in the I row of the ICE table. Both reactants reach 0 at the endpoint. The 1 to 2 ratio gives 1 times 10 to the minus 3 moles of oxalic acid in the sample. The full solution has 10 times this amount, or 1 times 10 to the minus 2 moles. The hydrate molar mass is 1.26 divided by 0.01, which is 126 grams per mole. Subtract 90, then divide the remaining 36 by 18. Therefore, X is 2. Question 16. Calcium carbonate decomposes to form calcium oxide and carbon dioxide. Calculate the atom economy for calcium oxide. First, write the balanced equation. The relative formula mass of the desired product, calcium oxide, is 56.1. The total formula mass of the reactant, calcium carbonate, is 100.1. Divide the desired product mass by the total reactant mass and multiply by 100. The atom economy for calcium oxide is 56%. Question 17. Compare the atom economy of the aluminium and carbon monoxide routes to iron. State which is higher and explain why atom economy alone is not enough. For route A, iron 3 oxide reacts with 2 aluminium to form 2 iron and aluminium oxide. The desired iron mass is 111.7. Divide by 213.66 and multiply by 100. Route A is 52.3%. For route B, iron 3 oxide reacts with 3 carbon monoxide to form 2 iron and 3 carbon dioxide. Divide 111.7 by 243.7 and multiply by 100. Route B is 45.8%. Route A has the higher atom economy. However, a real process must also consider percentage yield, energy use, toxicity, cost, emissions, and whether materials can be recycled. Question 18. The theoretical yield is 4.8 grams, but the actual yield is 4.02 grams. Calculate the percentage yield. Percentage yield equals actual yield divided by theoretical yield, multiplied by 100. Substitute 4.02 divided by 4.8, then multiply by 100. The percentage yield is 83.8%. Question 19. 6.54 grams of zinc reacts with excess hydrochloric acid. The actual hydrogen volume is 2.1 cubic decimeters at STP. Calculate the percentage yield using 22.7 cubic decimeters per mole. The balanced equation gives a 1 to 2 to 1 to 1 ratio. The zinc amount is 0.1 mole. Place 0.1 mole of zinc and excess hydrochloric acid in the I row of the ICE table. All zinc reacts. The 1-to-1 ratio gives 0.1 mole of theoretical hydrogen, multiplied by 22.7. The theoretical hydrogen volume is 2.27 cubic decimeters. The percentage yield is 2.1 divided by 2.27, multiplied by 100. This gives 92.5%. Question 20. 12.25 grams of potassium chlorate decomposes with a 75% yield of oxygen. Calculate the actual oxygen volume at STP using 22.7 cubic decimeters per mole. The balanced equation shows 2 potassium chlorate producing 2 potassium chloride and 3 oxygen. The potassium chlorate amount is 0.1 mole. Place 0.1 mole of potassium chlorate in the I row of the ICE table. The 2 to 3 ratio gives 0.15 moles of theoretical oxygen. Multiply by 22.7. The theoretical oxygen volume is 3.41 cubic decimeters. Take 75% of the unrounded theoretical value. The actual oxygen volume is 2.55 cubic decimeters.